Hello everyone, I've asked to do another equation once more, this time taking into account the lovely pesky transition metals. We know that a transition metal is in this lovely worded equation because of one key factor. This one has brackets in the words. You can see this brackets follows iron. Now if we're looking at our periodic table, iron is Fe and falls right in the middle of this no man's land. This no man's land being those transition metals. Now you can see that my plus 1, plus 2, plus 3, plus minus 4, minus 3, minus 2, minus 1, and 0 don't allow for anything in this area. That's because this one actually has a much easier cheat code. If we look straight away in the brackets, it will tell us its charge. In this case, it's telling us a charge of 3. Now we know that it is a plus because anything in this tiny little section is a minus, and everything over here has a plus charge. We know that because it is a metal. Metals are positive. So in this case, I have a plus 3 charge for iron. Now, as before, we went through the lovely equation, and as we read it, we will highlight the parts that have the elements. As you can see, I've already done this, so sodium hydroxide is definitely sodium an element. Hydroxide, being one of those polyatomic ions, reacts with iron. Nitrate, once again, another polyatomic ion. We can tell that because of the 8 ending, whereas hydroxide has hydrogen and oxygen, even though it has that "ide" ending. Both of these are polyatomic ions. To create a precipitate of iron 3 hydroxide, once again, that's where that one's coming from, in a solution of sodium nitrate. So what will this look like if we write it out in symbol form? Well, we all remember my lovely joke for sodium. Sodium being Na. So sodium hydroxide is getting added to iron 3 nitrate, and together they are making iron 3 hydroxide plus sodium nitrate. Now, all we can see is this has been a very simple method of swapping partners. You can see that iron, who was previously partnered with nitrate, is now partnered with hydroxide up at the top, where sodium has swapped partners with iron and has now ended up as a partner with nitrate. You can see that that is just an example of a double displacement. Both of them have displaced their partners. So we've had a bit of a swap. Now, when we look at the symbols on this one, once again, my joke about sodium, Na. And our lovely symbol for oxygen, hydroxide, is that lovely O. And going across to be added with, sorry, Fe, and we know the charge for that one, we'll work it out in a moment. And then I have nitrate, which is NO3. We can put that in a bracket as well. Arrow coming across, I've got Fe, brackets OH, plus sodium, Na, brackets NO3, close brackets. Now, that is my first step. We can see that I have not yet done their lovely partners or their charges. So for this, we need to work out their charges. Now, as I said, anything that looks like that or that, once again, that 8 ending or having more than one element up in that front section, hydrogen and oxygen, means that they are in my polyatomic ions. So, unfortunately, this periodic table is only really good for my sodium. Sodium being a plus 1 charge. Now, OH, I can tell you right now, is a minus 1 charge. And then Fe, well, that lovely 3 gave us a hint as to what I need. So 3 up there, plus 3. Sorry. And when we look at NO3, NO3 actually has a -1 charge. Once again, Fe has that +3 charge, OH -1 charge, and A is a +1 charge, and O3 -1 charge. First step we would do is to find out what the balance combination of these are. So in this case, we would do a swap and a flick. In this case, it's not really necessary for NaOH because both of them are 1s. Once again, we ignore the pluses and the minuses. So one goes down there, one goes down there. I know I have NaOH plus Fe. Well, that's got a 3 there, and that's got a 1 there. So that 1 will go down to Fe, where this 3 will actually go all the way outside that brackets. Which means I will end up with Fe1 brackets NO3 close brackets 3. Once again, that 3's come all the way down here. We will arrow that across and do the same on the other side, because we can see that that 3 needs to come down there, where that 1 goes down here. So I end up with Fe, open brackets, OH, close brackets, 3, plus, once again, these are 1 and 1, so that 1 and that 1 don't make a difference, so I end up with NaNO3. Fantastic. Now that we've got it up to this point, my next step would be to balance the equation. Once again, my rules of my balancing equation come in my step-by-step formula, so let's follow this along the way. First step we would do would be to box these now perfectly paired partners. Box this one. Once again, I will point out it is everything before the plus, everything between the plus and the arrow, everything between the arrow and the plus, and everything after the plus. Well, that needs to be boxed. So box 1, box 2, box 3, box 4. All of these, once again, are like brand names, and we need to keep them boxed up because we do not want to accidentally put a number in the wrong spot. Next part we will do is split it. So we do an arrow right down where the arrow is, so a nice big line down there, and a line across, just to symbol it off. Now these are my reactants, and these are my products. So much like you and your siblings, they are two different things. Two different things, and if we are considering these elements like a treat that you are getting from your parents, well, we know that each sibling needs to have exactly the same amount. For if these were M&Ms, if I gave you 6 on this side, I guarantee your brother will count every M&M I give them and make sure that they have 6 as well. Well, let's have a look with our elements and actually find, well, what's in the box, and let's see if they are in fact balanced. So the first part, I have Na. That number down the bottom says 1, so I have 1 Na. I have 1 O, and I have 1 H. In fact, because I have OH on this side, I have OH on that side, I can actually treat them as one symbol. So by trapping in a box, I trap it in, and I can treat them all as one. Next one that I can come across would be Fe. Now we can see that we've also got NO3 in the brackets. Well, I've got NO3 on that side. Let's put that on the brackets as well. And let's treat NO3 as a single element. So NO3. Whilst I do understand it's not a single element, it is a polyatomic ion, and therefore we are treating it as itself, which is that polyatomic ion. So I'll keep them as their 3's. Once again, that 3 telling me I have 3 lots of everything in the brackets. Yes, you can break it up, but for this purpose, it might be easier for you just to keep them together. So let's move on to the products. I've got Fe, and then I've got 3 OHs. OH, OH. And come across, I've got 1 Na, and I have 1 NO3. Perfect. We've worked out what's in the box, now comes the time to balance it. As you can see, there's no hydrogen, so our lovely rule of H is last doesn't apply here. We can actually completely ignore it. So let's get straight into it. NAs, Na and Na. Well, they're both balanced, so I don't need to touch that. But I've got 3 OHs on this side, I have 1 on this side. So in order for me to get 3 on this side, I do have to put a 3 outside of it. And once again, the only place I can put that 3 is outside of the box. Consider this like ordering a box on eBay or from your cafe. You can't order something like a can of Coke and ask for just the O's in the Coke. It's not going to work. In this case, I can't just ask for the OH and say, hey, yeah, I need 2 more of those, so let's make it 3 of these with 1 of those. I cannot do that. Everything in the box comes as 1. I cannot change the order. So here we would have 3 times everything that's in the box. So let's put those new ones in, 3 NAs and 3 OHs. Well, now I've got all my OHs sorted, however, I do not have my NAs. So let's go back to those NAs. I have 3 on this side. Let's get another lot on this side. So put a 3 at the front of that one. That 3 matches 3 there, 3 there. So I now have Na, Na, and I have 3 times NO3. So NO3, NO3. Moving across, let's go to Fe. I've got 1 of each, that's fantastic. I've got NO3, 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 so 3 on that side, 3 on that side. Perfect, let's check it. So, 1, 2, 3, 1, 2, 3. We can tell that because there's 3 in front of that one, 3 in front of that one, and they have no subscript there, which means I only have 1 of them. In this case, I have OH with no subscript, but I have 3 in front, so I've got 1, 2, 3. In this case, I have 3 at the bottom there that says 3 of everything in the brackets. So I've got 1, 2, and 3. Matched. I have 1 Fe, I have 1 Fe. I have 3 lots of NO3, so I have 1, 2, and 3. I have 3 lots of NO3. 1, 2, 3. Everything is crossed off, which means now we're balanced. To write it out officially, we would get our lovely pen out and we could write it as 3 N A O H. Please notice how I left out the brackets on that one. It's because it is not compulsory and that brackets is purely to help you. The next one would be F E brackets. It is compulsory on this one because we have that 3 down at the bottom there. N O3 with that 3 on the outside, and what this is going to be adding to, I'm just going to change my pen, is going to be F E brackets O H close brackets 3. Because we've got that subscript out of it, we need to put those brackets in. Add that to 3 N A N O 3. Once again, those brackets not needed because there's no subscript outside of the NO3. So it means everything after here is in that equation. Sorry, we'll bump that up so you can actually have a look-see. Now, what we've got here is everything in purple, is my reactants, and my reactants are coming together to make my products, which are my blue. Congratulations, you've just balanced another equation.